Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to multiply rational expressions. Once again, I will assume that you are familiar with simplifying numerical fractions, properties of exponents, factoring, and simplifying rational expressions. Now we start by understanding the basic principle of how to multiply two fractions or rational expressions. If I have, for instance, a over b times c over d, to multiply these two rational expressions, I simply multiply across the numerator and across the denominator. So a over b times c over d gives me ac over bd. So what we'll do is we will do that for any rational expression, but we'll also need to then simplify it. Consider the following example. So using the principle we just looked at, we simply multiply across the numerator. We have 3 times 10. I'm not going to multiply that out because it's going to make it harder to simplify if I do that. And then we'll have a squared b to the fourth c cubed times d. And in the denominator, we multiply across the denominator. And we have 5 times 21 a b to the fifth c d cubed. I just rewrote those factors in the same order they were in the numerator to make my life a little easier. And now we simplify this rational expression. So 3 and 21 have a common factor of 3. So we cancel that out, leaves us with a 7 in the denominator, a 1 in the numerator. 10 and 5 also have a common factor of 5. So we are left with a 2 in the numerator and a factor of 1 in the denominator. And then as far as the variable factors, we have a squared over a. So that will cancel out a. We'll be left with a factor of a in the numerator. We'll have b to the fourth in the numerator, b to the fifth in the denominator. So we'll cancel out entirely the b to the fourth. It'll leave us 1 power left over in the denominator. For c, we have c cubed in the numerator, c in the denominator. So that will completely cancel out the factor of c in the denominator and leave us with c squared in the numerator. And finally, d, we have d over d cubed. That will cancel out the factor of d in the numerator and leave us with d squared in the denominator. So what we end up with, putting this all together, we have 2 ac squared divided by 7 bd squared. And that's it. Example 2. Now before we multiply, we should factor anything we can factor from these two rational expressions. So the first rational expression, that numerator is a perfect square. So we can factor, it's actually 2x plus 5 squared. So it's 2x plus 5 squared. And in the denominator, we can factor out a common factor of 3. So it's 3 times x minus 1. In the second rational expression, in the numerator, we have a common factor of 15. So we can factor that out, and we have left with x minus 1. In the denominator, that is a difference of squares, but before we factor as a difference of squares, we want to factor out the common factor of 4. So that leaves us with 4. Once we've factored out the 4, let's do an intermediate step over here, right? We'll have 4x squared minus 25, and that is still a difference of squares. And so we're left with 2x plus 5 squared over 3 times x minus 1 times 15 times x minus 1 over 4 times 2x minus 5 times 2x plus 5. And now we multiply across and we cancel out common factors. We have 2x plus 5 squared times 15 times x minus 1 all over 3 times 4 times x minus 1 times 2x minus 5 times 2x plus 5. Now, canceling out common factors, we have a 2x plus 5 squared in the numerator and a 2x plus 5 in the denominator, so we can cancel out 1 power of that in the numerator, and we cancel out the 2x plus 5 entirely in the denominator. We also have a 15 in the numerator and a 3 in the denominator, so we can cancel out the factor of 3 there. This will leave us with a 5 in the numerator. And finally, we can also cancel out the x minus 1 factor in both the numerator and denominator. This leaves us with our final answer, of 5 times 2x plus 5 over 4 times 2x minus 5. Here's our final example. We start by completely factoring all of the polynomial expressions in the numerators and denominators. So we start with our first rational expression. In the numerator, x squared minus 4 is a difference of squares, right? It'll factor into x minus 2 times x plus 2. In the denominator, x squared plus 5x plus 6 will factor into x plus 2 times x plus 3. And if you want to, you can actually just completely we already have that common factor of x plus 2. You can just cancel them out. You don't have to keep writing them. In the second rational expression, x squared plus 6x plus 9 is a perfect square. It will factor into x plus 3 squared. And in the denominator, x squared plus 2x minus 8 will factor into x plus 4 times x minus 2. And now we simply multiply across. So we're left with x minus 2 times x plus 3 squared over x plus 3 times x plus 4 times x minus 2. And so now we just cancel out common factors between the numerator and denominator. We can factor out this x minus 2 from the numerator and denominator. We have x plus 3 squared in the numerator and x plus 3 in the denominator. So we can cancel out one factor in the numerator and then cancel out that x plus 3 in the denominator. And that's it. So this leaves us with our final answer of x plus 3 divided by x plus 4. And that is multiplying rational expressions. Now, where you're going to have trouble with these is the factoring is going to be really important. So if you're not comfortable with factoring, practice that a lot. Okay, until next time, have fun.